10th away. Okay, 1.6.
An 8 for resourcefulness with 10.
I will do my best to have some group work, class work. Maybe we can fit it in before the first test, before each test, in which you can work together on several problems. I will try to do that. For now, I'm just on a race against time. But we will have class work and we will prepare for the test. But please redo the problems we do in class first, okay? Please. Okay, other types of equations. So let's list what we know. We know linear. We know rational. And we know quadratic. We're going to look at polynomial, radical. We're going to look at with equations with rational exponents. I think, in my opinion, they're a little weird. Not difficult, but we are going to look at equations that are with absolute value. We are going to look at quadratic in form. Not quadratic, but quadratic in form. With a substitution, yeah.
Oh,
With a substitution, yeah, quadratic in form.
Just called it different.
And much later, we're going to look at exponentials. Exponential equations, you don't have to write these two, and log. And this will be the end, but this is later for the next test. Okay? So this will be pretty much what we studied this semester. We know these three, we're done here. Polynomial, radical, equations with rational exponents, equations with absolute value, and equations quadratic in form. So let's start with that. Polynomial. And you should say, wait a minute, but what about linear and quadratic? Aren't they polynomial? Aren't you done with this? No. Because when we really talk about polynomial equations, we mean degree 3 or more. So when we say polynomial, we mean degree 3 or more. When we say linear and quadratic, we mean linear and quadratic. Okay, let's choose. We're on page 185. Questions? Okay. On page 185, I like to choose 4. If you want to choose, feel free. 185. Okay. And equation 4, 4x cubed minus 12x squared equals 9x minus 27. Okay, I'm going to ask you what type of equation is it? Of course, it's polynomial. Of course. Good. What do you think we have to do? Move everything to one side, of course. Thank you very much. 4x cubed minus 12x squared minus 9x plus 27. Now I go back to what I reviewed last week. Okay, it's a polynomial. It's in descending order. Greatest common factor? No. Negative leading coefficient? Good. What do we do with 4 terms? That's it. Very good. Okay, from the first two? Excellent. In parentheses? In parentheses again, it's a must. And I have to copy equal symbol and 0. X minus 3, correct, right? The same thing, good. We cannot fabricate it, but is it there? It should be there. What is it?
4x squared minus 9.
Very good. Factor where does that come from? Okay, so then we factor out the common factor, which is x minus 3. 4x squared minus 9. And then x minus 3, we know how to factor this. We studied it last time. Awesome. And I forgot to ask you a question from the very beginning. My apologies. What is the degree of this polynomial? How many solutions do I have to write? Exactly. Please remember the number of solutions, even if they're all the same. If the degree is 3, I have to present 3 solutions. If the degree is 15, I have to present 15 solutions. They may all be the same. Good, so then you will give me 3 solutions. The first solution will be excellent. Okay, so positive 3 over 2 and negative 3 over 2. So 3 is coming from the first factor, 3 over 2 from the second factor, negative 3 over 2 from the third factor. Are you with me? Please, any question?
What makes a degree 3?
Very good. The degree of this monomial is 3, the degree of this monomial is 2, the degree of this monomial is 1, the degree of this monomial is 0. The highest degree goes over all of them. So, very good question. Let's go back.
The highest exponent.
The highest exponent, yes, but for monomials is different. So that's why I wanted to. Okay, so right about here. What is the degree of this polynomial? How many solutions we get? Correct. Very good. Moving on. Let's look at another example before we continue with other types. Number 2. 5x to the 4th minus 20x squared equals 0. What type of equation is this? Excellent. What is the degree?
4.
How many solutions? 4. So degree 4, solutions 4. Please remember we're going to get to chapter 3 and this will be very important. Very important. Degree 3, degree 4, 4 solutions. Very good. Next step. You know what I'm going to do. Please just say it and I'll do it. I will divide by 5 because it's an equation. Never divide by x. I'm not saying you meant to, but I need to write this down. Never divide by the variable. Please remember, I can divide both sides by 5 and get x to the 4th minus 4x squared equals 0, but I cannot divide by x. X or x squared is a common factor to both, but I cannot divide it. Why? If I do divide, I will never get 4 solutions. I will only get 2. Good. It's a binomial. It's in descending order. Greatest common factor? Perfect. What is left in parentheses? How do I factor x squared minus 4?
X plus 4. I mean, x plus 2, x minus 2.
Excellent. Well done. Oops. Minus 2. I need 4 solutions. Even if some of them are the same, I still need 4 solutions.
0, 0.
Exactly. The first 2 are x equals 0 from the factor of x squared, which is x times x. Great job. And then?
Minus plus 2.
Excellent. Well done. Questions? Please.
In the beginning, what makes you just be able to divide by 5 instead of factoring out 5?
Excellent question. Excellent question. If you give me this expression and you say factor, okay, factor completely. No factor can go away. Everything has to stay. But if you ask me to solve the equation, I will first divide by 2. And then I will take the square root. Because in an equation, dividing both sides by a non-zero number simplifies the equation without changing the solutions. Can you still carry that 5? Yes. But here's what some of my students do, and it makes me cry. So they keep the 5 instead of simplifying because it's an equation. Here I cannot disregard anything because I'm factoring. But here I can divide both sides by 5. So they keep the 5. They keep the 5 here. And they say that there are 5 solutions. One solution is when 5 is 0. And then my head explodes. And then 2 solutions, x equals 0. And then x equals -2 and x equals 5. X equals 2. So they come up with 5 solutions. And first solution is 5 equals 0. So that's the reason why I always simplify. Now, if you know what you're doing, you don't have to divide by 5 if you don't want to. But it's always important to simplify. It will make it much easier to solve. Once you get rid of 5, you cannot get rid of x or x squared. That's absolutely impossible. But simplifying by 5 will not change the solutions. And why not? I don't need to carry that. Very good question. Thank you. Anything else here? Anything else? Okay, we have roughly about 12 minutes. Let's continue with radical equations. That's the next step. Radical equations, we are on page 185. I'm going to choose a simple example and not from the book because I don't see a simple example. I want a simple one first. So let's say the square of x plus 1 equals 2. Before we look at this, I'm going to ask you a question. Let's say we have this equation. It's linear, correct? And let's say I decide, and you will say why, and I will say I have no reason, I just want to show you something. I'm going to decide to square both sides. I have no reason to do that in this case. But let's suppose, bear with me, and I square both sides and I get x squared equals 4. But now this equation has how many solutions? It has x equals 2 and x equals -2, as we know when we take square roots. Remember, I started with x equals 2. This is okay. 2 equals 2. But what about this? Is this correct? So the point I'm making here is we will have to square both sides because that's the only way to undo the square root. Only if we square both sides. But this is not to be confused with, let's say I have a fraction and it's 1/2 and I want to square the top and the bottom. You cannot do that. So this is an equation. I'm allowed to square both sides. However, as you notice here, I obtained a solution after squaring that did not work in the original problem. Which means after I'm done, I have to go back and check. This is not a legitimate operation. Squaring both sides is not legitimate. What is legitimate is adding 9/4 to both sides. No change. Subtracting 5 from both sides. Dividing both sides by 5. Those are legitimate. The solutions will not change. But squaring both sides is not legitimate. I squared here, and look what I got. And one of them is off. One of them does not work in the original problem. So then, after we square and we get x plus 1 equals 4, hence x equals 3, we have to write a question mark and say, does it work in the original problem? Because it may or may not. So I go back. This is not the original problem. This is the original problem. I plug in 3. 3 plus 1 is 4. The square root of 4 is 2. And after that, I will say yes. It works. Why did I have to go to back and check? Because I used a method or a principle that is not 100%. And now we can look at more complicated situations. On page 185, let's start with still a simple one like 11. The square root of 3x plus 18 equals x. This is really the next level. Yes, please.
What page are you on again?
Same one, 185. Okay, so then what do I do? Now, is the radical isolated on one side? The answer is yes. And there is only one term on the other side, just x. Perfect. So let's square. When you square the left-hand side, what do you get? 3x plus 18. And when you square the right-hand side, x squared. What type of equation is this? I should have asked from the very beginning. What type of equation were we given to solve? A radical equation, indeed. We were given to solve a radical equation. Good. So then, now, because it's quadratic, I have x squared minus 3x minus 18 equals 0. I have 4 methods. Which of these will I use? Yes, because it does not take long. If it takes too long, forget it. Absolutely. So,
X minus 3 and x plus 6.
yes, x minus 6 and x plus 3, or x plus 3 is minus 6. Perfect.
Positive 3 and a negative 6.
So x minus 6 and x plus 3, positive 6 and negative 3, and they come with a huge, huge question mark. I have no clue. I have to go back to the original problem, which is this, and see if they work. One or just two, or both, or none. So, when I plug in 6, 3 times 6 is 18. 18 plus 18 is 36. The square root of 36 is 6. So I will say x equals 6, yes. Now I plug in negative 3. I know it's not going to work. It's a square. It cannot be a negative number. So negative 9 plus 18 is 9. The square root of 9 is 3, and the other side is negative 3. Is this correct? No. So I will say absolutely not. This is the only solution. I don't want to move on to another equation. I think we should just choose one more to work on. And then we'll stop. Let's look at 16. This is a slightly more difficult situation. You'll see in a moment why. What type of equation is this? Perfect. Is the radical isolated? If the radical is completely isolated, alone on one side, nothing touches it, just the equal symbol. Completely isolated. Good. So now the next step. Yes, but remember you cannot square term by term. You square the left-hand side as 1 unit. You square the right-hand side as 1 unit. The left-hand side, please. Now be very careful with the right-hand side. We are squaring a binomial. How many terms will you give? 3 terms. I'm ready when you are. Yes.
Minus 2x plus 1.
Awesome. If I convinced one student to use the formula, I reached my target. I managed one student to pull into my corner. And I think at least one is in my corner. One goes away. It's quadratic. I move 6x. I factor out x. And I get 2 options. Please check. In the meantime, I'll take attendance. And please tell me which one works. Or maybe both. I don't know. Of course, I'm logged out. No surprise there. Are you surprised that I'm logged out? No. Do they work both? None? One? None? Okay. 0 doesn't work because, okay, I got it. 8 minus 1 is 7. 48, 49, yes. I completely agree.